Alright, welcome back everybody. This is the second video for Section 5, Unit 2 of AP Calculus, applying the power rule. We ended our first video last time by looking at the power rule itself after we developed it, that the derivative of any function of the form x to the n, where n is a real number and x is a variable, is going to be n times x to the n minus 1. So we're going to go ahead and do a few example problems applying this, and hopefully you'll find pretty quickly that this is a very simple rule for us to apply. Let's look at the first example, part A. F of x equals x to the 4/3. So that means that f prime of x is going to be, and all we do is in the power rule, is we take the power, bring it out in front, and then subtract 1 from the power. So we're going to take this power, bring it out in front, and then we're going to subtract 1 from the existing power. And I would normally never write what I just did. I would just go straight to this step. 4/3 minus 1 is 1/3. And so there's my derivative. All right. Let's take a look at part B. F of x equals x to the 7th. So the derivative of that using this rule, I'm going to have f prime of x is equal to, bring the power in front, drop the power by 1. Boom, there's our derivative. All right, part C. F of x equals 1 over x squared. Now before I can use the power rule in this one, I need to get this into the form x to the n power. So I'm going to rewrite f of x, instead of as 1 over x squared, I'm going to write it as x to the negative 2. And then I'll take the derivative of that. And so f prime of x is going to be equal to, bring the power in front, drop the power by 1, negative 2 minus 1 is negative 3. Now, me personally, I would probably, since we started with it in fractional form, I would probably go back to fractional form for my answer and bring this down into the denominator and write it as negative 2 over x to the 3rd. Although this answer right here is totally acceptable, it's correct. But I tend to prefer to go back to whatever form I started in. I like to go back to that form in the end. All right, part D. F of x equals the square root of x. All right, so the square root of x can be rewritten in power form as x to the 1/2. And so f prime of x is going to be equal to, bring the power in front, subtract 1 from the power. And now I'm going to go ahead and do a little bit more with this. Since I've got that negative exponent, if I bring that down into the denominator, I can make it positive. And then x to the 1/2 is just the square root of x. And so this derivative is 1 over 2 square root of x. I've seen this so many times in my life teaching calculus that I just jump directly from square root of x to 1 over 2 square root of x without even any thought anymore. It's just kind of one of those things that has been bashed into my brain. All right, next, E. F of x equals 1 over x. 1 over x is x to the negative 1. So we're going to use the power rule. Bring the power in front, subtract 1 from the power. Negative 1 minus 1 is negative 2. And so this is equal to negative 1 over x squared. And the last one, f of x is equal to x to the pi. Again, we can apply the power rule here. And so this is going to be, bring the power in front, subtract 1 from the power. And I'm just going to go ahead and leave it like that. It's nicer to leave it as pi minus 1 than it is to, try and write pi minus 1 as anything else, especially since pi is an irrational value. Okay, so there's our first example of this video, example 3. Now let's go down and look at example 4. In example 4, we're supposed to determine which function and at what value the derivative occurs, which is represented by the following limits of difference quotients. Then find the value of the derivative of the function at that point. So we're going back to the idea that the derivative at some value a is equal to the limit as h goes to 0 of f of a plus h minus f of a all over h. So if we're trying to determine which function and at what value the derivative occurs in these, okay, I can really, use some information here to get me on my way. First of all, I can see based off of this difference quotient that this is something raised to the third power. So in part A here, my function is going to be f of x equals x cubed. And what's the numerical value that we're substituting into this limit of a difference quotient? Well, this is f of 2 plus h, and this is f of 2. So this is at x equals 2. Okay, so now that I've identified that this represents a difference quotient for the function f of x equals x cubed at x equals 2, what I want to do is I want to find the derivative of the function at that point. Well, I can take the derivative of f of x here by hand. F prime of x is just going to be 3x squared. And f prime of 2 is going to be 3 times 2 squared, or 12. If you remember a few lessons back, we looked at how to approximate the derivative using the numerical derivative function on our calculator. I can go ahead and do a double check of what I did here. Take the derivative of x cubed with respect to x, evaluate it at x equals 2, and I get 12, confirming my answer. All right, let's look at part B. The limit as h goes to 0 of the quantity 8 plus h to the 4/3 minus 8 to the 4/3 all over h. So my function here, well, what am I doing to a plus h and to a? I'm raising them to the 4/3 power. Where am I doing it at? Well, the value that I'm substituting in is 8. And so now I'm going to go ahead and take the derivative of this. F prime of x is equal to 4/3 times x to the 1/3. And so f prime at 8 is going to be equal to 4/3 times 8 to the 1/3. 8 to the 1/3 is 2, and so our derivative at 8 is going to be 8/3. And again, I can confirm that using my numerical derivative on my calculator. I happen to have a calculator that will give me back fractional values for, will give me back exact values for these. If you don't, yours probably will give you a decimal value here, but we're taking the derivative of x to the 4/3 and evaluating it at x equals 8. And if I go ahead and do that, it tells me that it's 8/3. Yours might give you 2.6 repeating instead. Okay, that's it for this lesson on applying the power rule. We'll see you next time when we step into section 6 of Unit 2 and begin looking at some more derivative rules. All right, everybody have a great rest of your day, and we'll see you next time.